Why is a method not identical to itself? The Python documentation about the is operator says, the operators is and, is not, test for object identity, x is y, is true if and only if x and y are the same object. X is not y, yields the inverse truth value. Let's try that. The Python documentation also says, due to automatic garbage collection, free lists, and the dynamic nature of descriptors, you may notice seemingly unusual behavior in certain uses of the is operator, like those involving comparisons between instance methods, or constants. Check their documentation for more info. I searched for more explanations, but I was not able to find any. Why is c.m a c.m false? I am using Python 2.x. As noted in the answers below, in Python 3.x, c.m a c.m is true.
When you ask for an attribute of an instance which is a function, you get a bound method, a callable object which wraps the function defined in the class and passes the instance as the first argument. In Python 2.x, when you ask for an attribute of a class which is a function, you get a similar proxy object called an unbound method. This special object is created when you ask for it, and not apparently cached anywhere. That means that when you do, you are creating two distinct unbound method objects and testing them for identity. Notice that and work fine. im_func is the original function which the unbound method object is wrapping. In Python 3.x, incidentally, c.m is c.m, is true, because the, somewhat pointless, unbound method proxy objects were removed entirely and you just get the original function which you defined. This is just one example of the very dynamic nature of attribute lookup in Python. When you ask for an attribute of an object, it is possible to run arbitrary Python to calculate the value of that attribute. Here's another example where your test fails, in which it is much clearer why.
I assume you are using Python 2? In Python 3, c.m is c.m, but c.m is c.m is still false. If you enter just c.m at the REPL, I bet you see something like unbound method ... An unbound method wrapper does very little, except checking is instance self, CLS. Seems pretty pointless to create a wrapper for this? It is. So it was dropped in Python 3, c.m is just a function. A fresh wrapper instance is created on demand whenever the method is accessed. c.m creates one, another, c.m creates another one. Since they're different instances, c.m is not c.m. Closely related are the bound methods, which allow you to do f=img.method, f_args, but also cause instance.method is not instance.method. Upon instantiation, all functions defined in the class, read, all methods, except of course monkey-patched ones, become properties of the instance. When you access them, you instead get a fresh instance of a wrapper, the bound method, around the plain function. This wrapper remembers the instance, self, and when called with arg1, arg2, ... argn, just hands these onto the function, with self added as first argument. You usually don't notice because you call the method right away, but this is what allows passing self implicitly without resorting to language level trickery. See the history of Python for more details and, well, history.
Because CM is not a static method of the class C. Try it like this. Because static methods are like class variables, we only want one reference for them so that if we change their bound value, this change should be automatic in all the class and instance of this class. On the other hand, in your example, c.m is not a static method, so Python makes the assumption that it should be treated like a non-static method, so whenever you call c.m, it will return a new instance. NB, static methods are not like class methods.
If you want to see